welcome once again. My name is John Gabriel, and this is the new Calculus channel. And today I've got a nice short little video which I've been meaning to produce for many months, but haven't got around to. So the video will be about how to teach toddlers and students and mathematics educators and math professors the concept of measure and the operation of division, which none of them really understand. None of them really understand. So I'm going to be looking at two videos and showing you the different approaches that mainstream educators have and giving you some analysis on those. So the first one is actually a video that surprised me because I never expected somebody to use this concept. I thought that it was quite smart for this teacher here to say that if you're dividing 6 by 2, you're in effect measuring 6 using 2 as a unit. So let's see quickly.
A couple of ways to think about it, but one way is to say, well, how many times can this fit inside of the 6 that we are given? We're dividing by 2, so it can fit.
Okay, so he says how many times can it fit inside? Well, that's not strictly speaking accurate. In fact, it's not accurate because if it doesn't fit exactly, then the definition doesn't work. Okay, but it is a good approach to teach, to begin teaching division. And of course, he goes on to teach the concept with fractions. Okay, so he says, okay, how many times does a quarter fit into a half? Okay, and he shows you, yeah, it will fit in twice, right? Because of these two blocks. But now he's using an advanced concept of area, which is already way past where a toddler is, or even where a young student, a fifth or sixth grader is. Okay, so they haven't even defined area, and this is one very big problem with mainstream academics. They do not have a general definition for area or volume. So now, not to waste too much time on this guy, his name is, I think, Jason Gibson. Okay. Then the next lady is a Greek lady. And of course, I watched this because I wanted to see if there were any better videos in Greek. Unfortunately, there aren't. And she says, okay, now there exists a nice little clever trick for uh, that you can use to do division. So she carries on and she says, let's see what's going on here. And she says, okay, I'm going to, first of all, the first mistake is that she uses a colon, which that doesn't mean divide. That means it's a ratio. Okay, so never ever use that symbol when you should be using the obelisk symbol. What's the obelisk symbol? The obelisk symbol is this, okay? And this is not equal to a ratio symbol. Okay, wrong to use this. Now, and then she says, okay, the trick is that we're just going to write this guy down here like that, and then we're just going to turn it into multiplication. We change it into poloplasiasmo, which is Greek for multiplication, and then we flip the 2 over 5, like she's about to do now, and now you've got a multiplication problem, which she, by the way, she's clueless. She doesn't realize that multiplication is a lot more complicated than division, and it's actually defined in terms of division. So, although she's taught her students how to find the answer, she hasn't really taught them understanding. And I did put a comment here. Well, I tried to put a comment, but it's a kids channel, so I couldn't. So I sent her an email. I don't even know if she looked at it. But that being said, you can see that one of the big problems with mainstream academics is that they don't understand measure. And in Euclid's elements, the word for measure, metrici, is used about 145 times. So how do you teach a little toddler or a child the idea of measure? Okay, how do you teach them? Well, You could say, for example, tell them to measure things when they don't even need to explain what measure means. Tell them to measure things by giving them an object like that, and then giving them, let's say, a long string like this, okay? And then what they do is they take that long string, okay, and they return this part to you, okay? That's all they do. They don't need to know anything about numbers. And so now, of course, they're beginning to understand that that's what it means to measure. They have this primitive idea of measurement, okay? So it's the first step towards finding out what measure is. And this is what I call the teaching style of using a one-part string. So you just use an entire string like that. Then the next thing you can do is, because children don't know how to count, is you get them to use, say for example, a smaller string. Okay, so for example, a string like that, and then they can do it in two ways. They can, each time they do that, they can place a string like that, and then, didn't mean to do that, and then for the next one like that, and then for the final part, this little bit here, okay? And then they've measured the whole distance without counting. Okay, that's still geometric measure. So once they learn how to count, then they'll be able to take this guy here and divide it into equal parts so that they can give you the exact measure and count how many parts actually fit inside here. 1, 2, and how many equal parts of this guy here, okay? How many equal parts of this guy? And that would be the complete measure in algebra, okay? That's called measuring with the abstract unit and or equal parts of the abstract unit, which is different to geometry where you measure with the physical unit and or parts of the physical unit. They don't have to be equal. So essentially a measure is the same as division, is the same as counting, okay? These three things here are exactly the same. And your idiot math educators and professors don't know it. Because look, when you count, you're actually dividing, right? So if this has a certain number in it, you could count it this way, 1, 2, 3, 4, 5, etc. by adding them up, or you could subtract them, okay? So subtracting is the most primitive way of doing it, okay? Subtracting is the most primitive. Why? Because you cannot define difference. You cannot define difference instead of sum, but you can. So you cannot go this way, right? But you can go that way. What that means is, for example, if you have 1 minus 1, that's the same as 1 plus 1, right? Which is 2. Does that make sense? Yes. Okay. But you can't say 1 plus 1 like that and somehow get the difference of these, okay? And somehow get 0 on this side. There's no way you can do it. Does that make sense? Okay. And then of course the order of operator precedence is as follows. It's difference, sum, quotient, and multiplication. So I recommend that you read my free ebook called Learning the Correct Way. And that book, I'll place a link to it in the details section. And you can download it for free, or you can buy a copy on my Amazon Kindle. And that's what I wanted to share with you. Hope you've enjoyed this little video, and I'm glad I was able to make it. It's getting more and more difficult for me to make videos. Until next time, if you haven't subscribed, please subscribe, click like, and follow me on Academia.edu. Goodbye.